evening. Hello. Yes, thank you. Welcome. Good evening, everyone. We are so very delighted to have you with us tonight. My name is Colleen Murray Payton, and I am the chair of the Open Book Event Series, which is part of the Pasadena Literary Alliance. I'm also your friendly bartender. You may have seen me out there. Thank you. Thank you. We are so excited to bring you this program, and we don't do it alone. We are a group of volunteers. So I'd love to go ahead and first acknowledge all of the volunteers in the audience. So if you are part of the Open Book Committee, please just go ahead and wave your hand. Hello, see us all here. Thank you so much. We work together to bring these kind of events to the public, and especially Pasadena. So again, take a moment to silence your phone, any kind of noisemaker you have, if it's an iPad, phone, charger, pager, if you still have one of those, please turn it off. The Pasadena Literary Alliance is an independent nonprofit, and your donations are tax deductible. This year, we are approaching $500,000 in grants to local literary organizations after just completing in May our annual event hosting over 500 people at the Pasadena Convention Center for the Pasadena Festival of Women Authors. And we were so excited to be in person. Yes. Our mission to celebrate authors is ambitious. Open Book hosts authors of all genres of literature, fiction, nonfiction. But in addition, we attempt to conduct these open book events in the venues that reflect the theme of the book. We also do events online. So when we can find authors that wouldn't otherwise be able to be together, we're able to bring them together on Zoom and have conversations. So you can check that out on our website. We are so proud to be able to bring Emily Levesque to Pasadena, but to also, yes, there she is. There she is. Yes. But we're also so pleased to be able to bring you here to the Carnegie Institute for a perfect environment for this discussion. So tonight, I'm very pleased to introduce our moderator for this very special program, Dr. John Mulcahy, director, yes, there he is, and also your friendly tour guide.
Yes.
Yes?
Some of you.
Oh, yeah.
Erica got the others, gave them a choice.
Yes, and Erica Clark as well. John Mulcahy, Dr. John Mulcahy, is the director of the Carnegie Observatories and science deputy of the Carnegie Institution for Science, the Observatories' parent organization, which is based in Washington, D.C. Dr. Mulcahy's research focuses on many key areas in astronomy, including dark matter and black holes. In addition, he's a consultant to NASA and the National Science Foundation, and a scientific editor for the Astrophysical Journal. Yeah, that's what I said. I like it. You just got a wow.
Yeah. It sounds impressive.
For many years, John has also been active in public outreach and education. In 2002, for example, he launched the highly popular annual Carnegie Astronomy Lecture Series held every spring at the Huntington. Dr. Mulcahy received his BS in astrophysics from UC Berkeley and his Ph.D. from the University of Maryland. So, in addition to his astronomy career, Dr. Mulcahy is also a songwriter, a true multi-hyphenate. This is true. He wrote his first original song at age 9, we hear, and has had since his songs recorded by many artists and featured in hundreds of movies and TV shows. Yes, and oh my God, that's correct. That's the right reaction. Including TV shows including Sex and the City, 6 Feet Under, Dawson's Creek, and Dollhouse and Valentine. Mulcahy has also had a Star Trek character named in his honor. Yeah. Are you not a Trekkie? Okay, I don't think anyone someone else can say they have.
The world is not a turkey. Yeah, a little bit.
And most importantly, for this evening and the Pasadena Literary Alliance, Dr. Mulcahy is the person who recommended that we invite Emily Levesque to tell us about her own journey in astronomy. So with many thanks and gratitude, and without further ado, here is Dr. Mulcahy, who will introduce Emily Levesque and help us learn more about Emily's book. Please enjoy this evening and help me welcome the two of them.
Well, first of all, welcome to the Carnegie Observatories, everybody. I realize that most of you had not been here before, so this is a treat. Hopefully you got to see a few things on your way, and hopefully we'll get to see more of you in the future. And it's really an appropriate place for Emily's book, as we hear a lot of her book describes a lot of things that happened in this building, up in Mount Wilson, and particularly Last Stargazers Observatory. I know many of you haven't read the book yet. There's so many wonderful stories from Last Stargazers, which is super great. So let me just tell you a little bit about Emily first. She's a professor at the Department of Astronomy at the University of Washington. She's renowned for her work on the physical properties and evolution of massive stars. This is another thing she talks about quite a bit in the book. Somebody forgot something. There you go. She's also received many already in her relatively short academic career, some really impressive awards from the AAS, particularly the Any-Jump Cannon Award. She got in 2014 for her innovative work on gamma ray bursts, a really interesting topic that I've worked a little bit on. And in 2020, she received the Newton-Lacey Pierce Prize, this, which is a prize given really for the junior astronomer who's had the most impressive work in the last 5 years. And she describes this work at the very end of the book. And I think that's the work that was relevant for that prize, so it's really super exciting to read it. We're going to talk about that a little bit. In 2022, I'm going off script here. She got the Guggenheim Fellow. She was a Guggenheim Fellow as well in 2022. That's this year. She received her Ph.D. at the University of Hawaii and a bachelor's degree from MIT. And this is all, once again, described really wonderfully in the book, so I recommend that. This is a really interesting part of her bio, which the few young astronomers in the crowd will really enjoy. In 2015, Emily and two colleagues published a really influential paper which critiqued the use of the physics graduate record examination. This is the GRE. Some of you who've been to grad school, there's a physics GRE. Many of you in this room didn't have to do it. A few of you probably did. As an admissions cutoff, this was a tool that was used, particularly in my age and when she came into grad school, to really decide which graduate schools you got in. And I did horrible on this exam myself. So we survived. The answer is the award. These sorts of tests really mean nothing, which is basically what she found in this influential paper. There's really no statistical correlation between an applicant's score on this standardized test and their later success in academic careers. And we really are examples of this. This is really quite good. And I should say the AAS, the organization, our main scientific organization here, says this is no longer a mandatory thing for graduate school. So this is good for future generations. And of course, the real reason we're here is for her book, which I don't know. I assume most of you have not read the book. Has anybody read the book besides me? A few. Great. Excellent. Because I do have some questions for those of you who read it. And so the book came out in 2020. It's called The Last Stargazers, The Enduring Story of Astronomy's Vanishing Explorers. And we're going to ask about the Vanishing Explorers. That's one of the topics we want to talk about. I have the hard copy, and why am I blanking on the word? Since COVID, I can't speak. The paperback, thank you. The paperback version came out in January, right? Yes. And so that's what we have here. If you haven't, please grab a copy of it. And so please welcome me and joining Emily here tonight. We're going to start with some questions. I'm going to ask some questions, but I do want the audience to feel free to jump in. So at any point, if you have questions or comments, please do. What I have to say, what I love about this book is, I feel like I could have written this book not as well as you, but look, when I read the book, your story and my story sound so similar. I mean, I think you've captured really the life of an astronomer in a way that I mean, it's just so true to the life of an astronomer. When I'm reading it, I'm just going, wow, this is very similar to the experience I have. And to every last detail, and I think it's super exciting. But one of the things that I really loved was how you got into astronomy, because it's truly remarkable. So I wanted to start with this. So in the book, it's one of the early things you describe in the book, which is, you're going to read first. I'm asking questions. I completely forgot. Would you like to read some from the? Okay, right into the questions because I'm super excited to ask the questions.
That's fine. It'll be a good segue.
Yeah, actually. So yes. So I think one of the segues you're going to talk about how you got into astronomy, but feel free. We're going to have you read some segments.
Yes. So first of all, thank you once again, everyone, so much for coming tonight. This book originally came out in hardcover in August of 2020, which was incredible timing with the pandemic. The paperback came out in January 2022 when we were sure everything would be over. This is now the end of that January book tour. But it's great to get the chance to talk to people in person and to share a little bit of the book. So I did want to start by reading a bit from the very opening of the book. And one of the only other in-person events that I got to do for this book before the pandemic started shutting things down was an event with the Public Library Association, which was wonderful. I got to hang out with librarians, the people who love books the most in the world, and got to speak to other authors and serve on panels. And an interesting topic that came up at that event was talking about famous first lines of books, because everybody can remember the first line that just perfectly sets the scene for an infamous book, Call Me Ishmael from Moby Dick, or It Was a Dark and Stormy Night, which is how A Wrinkle in Time, one of my favorite books, starts. And I remember talking to other authors and thinking, well, my book, The Last Stargazers, is about the behind-the-scenes world of professional astronomy and the really surprising adventures that astronomers go on, and how sort of shockingly sweeping and huge and exciting this field is. So it got me thinking, all right, what's the opening line of my book? How do I set the tone for this incredible adventure story that I want to take readers on? So I'll read you the beginning of the book, and you'll get to see what the incredible opening line is. Because this is how the book opens. Have you tried turning it off and back on again? Going on. This phrase, repeated by weary IT specialists the world over, had possibly never prompted such horror. It was 1 a.m, and I was sitting in a chilly control room on top of the highest mountain in Hawaii. I was nearly 14,000 feet above sea level, 24 years old, and fighting through sleep and oxygen deprivation to salvage several hard-won hours of research time for my Ph.D. thesis on a piece of broken equipment. The equipment in question was the Subaru telescope, a 630-ton beast housed 1 floor above my head in a 14-story dome. The telescope boasted a pristine primary mirror more than 27 feet in diameter, the largest single piece of glass in the world. The mirror reflected starlight into a suite of some of the most sophisticated scientific cameras on the planet. It cost $47,000 per night to operate, and after submitting a 12-page science proposal to my department, I had been granted one precious night, tonight, the only night allotted to me in the entire year, to point this telescope at a handful of galaxies 5 billion light years away. So no, I had not tried turning it back off and on again. The evening had been going excellently until one of the control room computers had produced an unsettling bloop sound, prompting the telescope operator, the only other person with me on the mountain, to freeze in her seat. When I asked what was wrong, she explained that one of the mechanized supports holding up a mirror had just failed. But she went on to reassure me, "It's okay, I think the mirror is still on the telescope." You think? I replied, "Yeah, if it wasn't, we would have heard a crash." Solid reasoning, but not exactly reassuring. We'd apparently gotten lucky with how Subaru was positioned when those support mechanisms failed, preventing an immediate disaster. For now, it was still holding up the secondary mirror, notably smaller than the enormous primary, but still 4 feet wide, 400 pounds, and suspended 73 feet in the air, tasked with redirecting light into the camera I was using. Unfortunately, if we moved the telescope again, we risked dumping the secondary onto the floor. And that was if we were lucky. If we were unlucky, it would hit the primary on the way down. We put in a nervous call to the Subaru day crew, a group of engineers who worked on maintaining the 13 telescopes on the mountain during the daylight hours when the astronomers were asleep. The crew member we reached cheerfully informed us that this was probably the same error they'd seen earlier in the day. The mechanized supports were probably fine. It was probably just a false alarm, he kept saying probably. And turning the power off and on again would probably fix the problem. It seemed impolite to point out that we were talking about a multi-million-dollar telescope and not a modem. I didn't know what 400 pounds of glass hitting the concrete floor above my head would sound like, but I knew I didn't want to find out. I was also quite sure I didn't want to forever be known as the grad student who killed Subaru. I'd heard too many I broke the telescope stories over the years to ignore the fact that this was a very real possibility. One of my colleagues had destroyed an outlandishly expensive digital camera on a telescope by innocently touching two of the wrong wires together. Another had slammed the business end of a telescope into a movable platform inside the dome partway through a sleep-deprived night. Sometimes these sorts of failures weren't even anyone's fault. A gargantuan 300-foot wide radio telescope in West Virginia had just up and collapsed one evening, crumpling like a stepped-on soda can partway through an observation. I couldn't remember what exactly had caused the infamous West Virginia failure, but I was convinced the words mechanized support and probably had been involved. A cautious thing for me to do would be to call it a night, drive back down to the observatory sleeping quarters, and have the day crew carefully check things over the next morning. On the other hand, this was my only night on the telescope. Tomorrow, it wouldn't matter whether I'd experienced a mechanical failure, a false alarm, or even just a poorly timed cloud. Telescope time is strictly scheduled months in advance, and another astronomer would be arriving tomorrow to use Subaru for a completely different research program. All that would matter was that my night had come and gone without completing my observations. I would have to submit a whole new proposal, hope for another hard-to-get yes from the telescope committee, wait an entire year until my galaxies were back up in the night sky to try again, and hope that that night wouldn't have any weather or telescope problems. I desperately needed these galaxies for my thesis. Several billion years ago, each of them had hosted a strange phenomenon known as a gamma ray burst. Astronomers thought these bursts were coming from massive, rapidly spinning, dying stars whose cores were collapsing into black holes, cannibalizing the stars from the inside out and igniting violent jets of light that came streaking through the cosmos to arrive at Earth as flashes of gamma rays lasting mere seconds. Stars died all the time, but only a handful of them were flashing us like this, and nobody could explain why. I had built my entire Ph.D. thesis on the idea that studying the chemical makeup of these stars' home galaxies, the same gas and dust they had been born from, was the key to understanding why they exploded the way they did. Subaru was one of the only telescopes in the world capable of such observations, and the day crew had said it was probably giving me a false alarm. If I called off the night, I'd be giving up what could be my only opportunity to ever study these galaxies, losing a linchpin of my thesis research in the process. Of course, having the largest piece of glass in the world sitting in pieces on the dome floor wouldn't help matters either. I looked at the operator and she looked back at me. I was the astronomer, so with all of my 24-year-old, third-year grad student, still had to pay the young driver fee to rent a car wisdom, this was my call. I looked at the printout of my meticulously crafted observing plan for the night, which was falling further and further behind with every minute that Subaru sat idle. I looked at the fuzzy image of the night sky on my computer screen, coming from the small guidance camera that showed us where the telescope was pointed, to help astronomers like me find our way through a bottomless sea of stars. I turned the power off and back on again. And to find out if that worked,
It's a really interesting place to start a book because I think you feel a lot of the emotions that as an astronomer you go through. That's one of the wonderful things about this book. I mean, it to me is, it's a wonderful career in many ways, but it's a challenging career, right? And often, and so I'm curious, this was one particularly maybe not so pleasant night. What has been one of the more exciting nights for you? Or as an astronomer, what's some of the more exciting things you've experienced?
That's a great question. I chose this story to start the book because it gets at a lot of the sort of emotional tenor of observing that I think people very understandably have a picture of astronomers as we're sort of like nocturnal mole people that just live at a telescope and wait for something to happen. And in reality, a lot of nights at telescopes are really tense. You're trying to rush, and there's sort of a built-in excitement saying, I have to observe this list of things before the sun comes up again. And if it doesn't work, this is my only chance. So the excitement is pretty constant. I think some of the coolest adventures were, I talk at one point in the book about observing at Las Campanas Observatory, so some of the beautiful Carnegie telescopes down there, and seeing just how mind-blowing the night sky is down there. It's something that will stop professional astronomers in tracks because of how beautiful it is. I write in the book about airborne astronomy, which which is a very niche field that not a lot of people know about, but it involves sticking telescopes into planes, flying the planes into the stratosphere, and then opening an airplane door to observe with the telescope, which was something I got to firsthand experience with. And I got to share my own adventures in the book, which was wonderful. I think being on a telescope plane was probably the coolest one that I got to share in the book. But I also talked to more than 100 colleagues. I interviewed you for the book. I interviewed a lot of other folks, and I heard wonderful adventure tales about being at observatories all over the planet, of discovering incredible new things. And the stories go from sitting at a computer in your office, but your heart racing because you just discovered another planet like Pluto, or sitting at a telescope shortly after a volcano has erupted nearby and figuring out what to do. So they really run the gamut. But there's a surprising amount of excitement in all of these stories.
It is. It's. I don't know how to describe it. It is. But you do such a great job in the book. It's like you never know what you're going to get when you go observing. This is one of the things, particularly, if you're observing from space. I'll explain this. If you have like the Hubble Space Telescope, so it's above the Earth's atmosphere, things can still fail as they occasionally do. But for the most part, you get your data from a Hubble. You kind of know what you're going to get. But ground-based observing, which is really what you're mostly, or even from an airplane, what you're describing here really is so dependent on so many factors. And there's a frustration that sometimes astronomy. You talk about another observing around Last Stargazers that didn't go so well, right?
Yes.
With the wind, for instance. I don't know.
So you can think of some easy cases where you would not want to open and run a telescope. If it's raining, you don't want to pour water onto that beautiful mirror. Or if it's a snowstorm or something like that. And I remember being at Las Campanas on a night when the sky was just pristine. There wasn't a cloud in the sky. It was beautiful. It was so wonderful to look up. But it was screamingly windy. And you can't keep telescopes open if the wind is too strong because you risk blowing sand and dust into the dome, and that will corrode the mirror. But when you're living through this at Las Campanas, every astronomer just lives and dies by the wind gauge because there's a wind level that it has to get below before you're allowed to open the telescope. And you watch it going 23, 22, you have to 21, 35. But it was an interesting example of somebody walking by might think, well, what a perfect night for astronomy this is. And we were closed the whole night because it never got low. We never got to low enough wind speeds. And it's amazing the quirky little things that will stop observing runs. I've talked to people who've had observing runs stopped by ladybugs. Swarms of ladybugs become an amazingly big problem for such tiny animals. They show up at an observatory en masse. And observing runs stopped because one piece broke on an instrument. So the amount of moving parts that need to work well to take the pictures that we all admire of the night sky are amazing. And then our own planet has to cooperate. There have to not be ladybugs, or not volcanoes, or wind, or any of the other things that a busy planet will produce. So.
Yeah, and I've lost more time at Last Stargazers from wind. I was telling people earlier, it's clear like 95% of the time. But the wind, I've lost a good fraction of nights to the wind, and that's the most frustrating because you said you can walk out, it looks beautiful, and yet you're not open. And so one of the other things that I think you briefly mentioned this in your book, but when you have a night like this, you're sitting there watching this for hours and hours and hours. 3 o'clock in the morning rolls around. I would just say, there's a point in the night where you're just like exhausted, and you're thinking, is the wind going to stop? When do you call the night? I guess is an interesting question, right? Because you have 3 hours left in the night. You said in your book you had the right political answer, which is you call the night when you know you don't have enough time, if it opened, to actually do anything. But oh boy, is it tempting when it's.
You want to wait until the absolute last minute, because I know people that have at 4 a.m. the wind suddenly died, gotten an hour of data, and especially when you're sort of young and going on your first observing runs, you start observing in the beauty of space and I'm a real astronomer, I'm working at a telescope. That's just propelling you with just adrenaline. And by 3 a.m., the beauty of space is a little. So you're sitting there thinking, wow, the galaxy's a beautiful place, but that pillow looks amazing.
It's so good.
So there is a point where, what I will do is I will start rooting for if it's going to work on offshoots of that project, and with that advisor. He's now a very close collaborator of mine, and we still work together to this day, which doesn't always happen. I've had lots of wonderful projects with advisors where we did great research together and really enjoyed it, but people then split off into other projects and move on, which is quite normal. But you had asked about how I had gotten into astronomy.
Yeah.
And as a kid growing up, nobody had to convince me that space was cool. I don't think you ever have to convince a 5-year-old that like black holes, dinosaurs, it's fine.
There's a list. Yeah.
But I didn't know any scientists growing up. Nobody in my family was a scientist. Nobody in my family had a Ph.D. I grew up in southern New England, about an hour south of Boston. There were no professional scientists there. My picture of professional scientists came from movies. So when I did this first research project, it was my first glimpse at how the world of professional science worked. And my advisor and now collaborator, who's a guy named Philip Massey, emailed me and said, I have 2 projects you can work on. You can work on blue stars or you can work on red stars. And these are both stars that are about 10 times or more massive than our sun. So they lead very unusual, very different lives than our sun. Our sun is going to live about 10 billion with a B years. These stars, by comparison, are really quick. They only live about 10 million with an M years. Wow. And these are the stars that when they die make things like black holes. And all I knew about these types of stars were that stars were born bright blue and very hot. They would cool off and puff up and turn into these red stars. And then they would die and make black holes. And I thought black holes sounded cool. I didn't know much about stars, but I figured, well, the red ones are closer to black holes than the blue ones, so I'll work on the red ones. And what seemed like a sort of arbitrary decision is now, like much of my career is spent working on red supergiants and on the sort of late stages of these stars' evolution. But that was my very first time observing at a professional telescope in Kitt Peak. That was my first time getting to do a research project, writing a research paper. I write about that first night at Kitt Peak in the book and about all the stories that astronomers told me when I sat down to dinner with them. And it was a wonderful intro to the field, both in terms of just how to use a telescope and seeing how astronomers use storytelling. Because all of these tales of, remember to drink coffee to stay awake, but stop drinking it at 3 a.m. or you'll never get to sleep. And hey, watch out, we have scorpions on the mountain.
Yes.
There was a woman who had a scorpion climb up the inside of her pant leg and sting her. True story. She works with me at the University of Washington. She's fine. People passing around like, I know a guy who was observing in a dome when it got struck by lightning. I remember being told these stories my very first night at the telescope and thinking, this is amazing. And years later, I think the seed of that is what wound up making the book.
Yes. It's
the way to welcome people to the field.
It is, and you're right, because I remember my first observing trip to Chile, I was told about, watch out for the tarantulas in your bed and shoes, which after 133 trip, they're huge. They are the size of your hand. Yeah. And I've seen the tarantulas, but I've been to Chile 133 times, I was telling people. I've never had one in my bed or in my shoe, but I don't keep my shoes on the ground because of those very first stories I heard the very first time I went as a graduate student. So it is true. We are good storytellers, I guess. I hadn't really thought of it that way. Scaring the next generation. Now, but your interest in astronomy goes even further back. I'm going to take you back to 1986 because that was an interesting year in astronomy. And so it's pretty remarkable. You were very young in 1986, but that was the kind of the first moment you may have realized the universe was interesting to you. Yeah. Tell us a little bit about that.
So the reason this goes to 1986 is because that was the last time that Halley's Comet made a close flyby of Earth.
Yeah, I'll remember it.
That comes by every 70, 80 something years. I think it's next due back in 2061.
Something like that, yeah.
Yeah, and 1986 was its last close flyby, and I was 2. But I have a big brother who's 10 years older than me. He was 12, and as part of a school project, he was asked to observe Halley's Comet. So our whole family went tromping out into the backyard. Neither of my parents are scientists by training. They're both scientists by nature. They're just curious about the world, and obviously this was going to be a whole family event. And we had a little backyard telescope. We had binoculars, and we're getting ready to try and observe Halley's Comet. And according to them, I was the typical sort of fussy toddler, and it was dark, and it was cold, and I was tired until they pointed me up, at which point I was spellbound. And they got me to look through the telescope. They just sort of pointed me at the night sky. And apparently from then on, people would ask me what I wanted to be when I grew up, and I would say, well, I want to be a ballerina or an astronomer. I want to be a firefighter or an astronomer. And then later on, a marine biologist or an astronomer. An astronomer just stuck. But it got sparked by that first sort of stargazing experience that I ever had when I was tiny.
Yeah, being 2 was that, or something of that nature. That's pretty early.
Little.
Yeah, that's pretty early. I had a very similar experience with is the question I want to ask, because I was about 5 when my parents started saying, I was fascinated. I remember, it's one of my first memories of a solar system model in my kindergarten. Like, they used to hang these models, of the solar system, and just being fascinated by that. My mom was a teacher and recognized that and started buying me books, and I eventually had telescopes. And so, very similar to you, it was like always, I always say I was born to be an astronomer. I'm curious, you interviewed a lot of astronomers. I'm curious how common we are, because our stories seem very similar, but are most of the people you talk to, were they always fascinated by this?
It's really funny because when I interviewed people, I never asked anybody what their origin story was as an astronomer, because I was curious about people's experiences at telescopes. In a lot of cases, I talked to people who'd been observing for decades, and I wanted to know how their experiences had changed. The book looks a lot at how the technology of astronomy is changing the way we do our jobs. I never asked for origin stories. Everyone told me anyway. It wound up being wonderful because there was a consistency in that something would click for people. But what made that thing click was really different. If you grew up in a city, a lot of times people would say, well, I went to a planetarium for the first time, and I learned what was actually up there, which I couldn't see because of city lights. Or people would go to college for one thing and then take a class in astronomy and just get hooked. Yeah. And there were a lot of people that were interested young. There was a whole generation of astronomers I talked to whose training, they would go to school, they went to school in the sciences and then spent time in the military during sort of the later half of the 20th century, and their military training then put them into free school. And they would say, well, you know what always fascinated me? I'm thinking of a couple of folks in particular who described being out on a boat in the Navy and admiring the night sky and thinking, when I get to college, that's what I'm going to do. But everything sort of got sparked by falling in love with the sky at some point, and there were very few cases where it hadn't started with, a sort of romantic love for what you were doing. And again, the romance gets you to 3 a.m. on a busy observing night, but it's what sparks a lot of people going into the field.
Right. So that's interesting. So it sounds like it is, our stories are not that uncommon then. It's funny because yesterday I sat through a training with some other scientists from Carnegie who are not astronomers, and we were asked to talk about our origin stories. And one of the Earth scientists said to me, well, we know yours. You looked up and saw some stars and were inspired. Sounds like that's kind of true. But one of the things that was interesting to me is, so I became an amateur astronomer. I really got super hooked on it. But of course, that's a very different experience than actually being a professional astronomer. And so I'm curious, for you, like you made that connection too. I mean, our lives, right, we had to do math and physics and all these sorts of things. It's a very different job in some sense. There's still a bit of that romance, but I'm just wondering for you, like, have you thought about that transition, or did it just seem like natural?
That's a really interesting question. I remember when I was about 8, we went to an open house at like a little college not too far from where I grew up, and there were some little telescopes on display there, and somebody who I now realize must have been an astronomy professor there, and I told him, I want to be an astronomer, what should I do? And he looked at me and he said, take all the math you can. And I was kind of like, well, okay. But I started looking at a lot of things like that as sort of the tool to be a scientist. And so you mentioned that your mom was a teacher. My mom was a teacher and librarian, and she always makes sure that the house is stocked with books. Yeah. So I had books to read growing up about what scientists did and what science entailed. So it meant that I was into my math classes and into my science classes early on, and I came to really enjoy that challenge. When I was maybe about 10 to 15, I got really into for a while the space program and reading about the Apollo program, and I wound up loving the fact that it took heaps of people solving all sorts of engineering problems to do something like put a person on the moon. And it helped to have that mentality going into the exhausting classes that I wound up taking at MIT that were terrifying at first, because I was able to think, okay, I'm drowning in first year physics, but this is what I need. Like, these are the tools I need to have. And I mean, those tools are constantly changing. Nowadays, people are taking heaps of computer science because that's becoming such an important tool for astronomy. And the students that I have, the astronomy majors that I have, all look at it as, this is what I need to get back to explaining the sky and explaining that love of space that got sparked.
So that actually was a follow-up question I meant to ask earlier. So you interviewed, senior professional astronomers. I'm curious about the new generation because you're teaching, so you meet them. Because as one of the points of your book, of course, is that how we do astronomy is changing, that, we never, you and I don't even get to look through telescopes anyways, but we at least got to go see the telescopes and use them. And that is a thing, as we'll talk about in a minute, that is changing rapidly. So I'm curious if the new generation, which is of course also grown up with Hubble Space Telescope images and computers and all this thing, if they have that same romantic feel. It sounds like the answer might be yes. I don't know.
A lot of them do. It's
That's
funny.
interesting.
I was talking to an undergraduate student today who was telling me that he's an astronomy major. He was at the astronomy conference that's currently happening in town, presenting research. But he was saying, I love the computational work that I do. I love the puzzles that I get to solve. But I want to still go to telescopes. I still want to go to a mountain and be able to admire the night sky and then go in and run a telescope. And the field is shifting into a different way of doing that. But the love of that is still there. And a lot of people, when they take their first observing class, and I write about this in the book, the first sort of observational astronomy class I got to take in undergrad, it was just amazing. And getting to be taught by some incredibly brilliant and experienced observers in the field, it gives you that glimpse of hands-on. So the love is still very much there. It just sort of manifests in different ways because you do your research maybe less with how we used to observe back in the day with, pictures captured on little sheets of glass to what we have now, which is pictures captured digitally. The methods are different, but the questions are still the same, and the curiosity driving it is still the same.
So I'm going to jump in. I'm going to ask a question that somebody in the audience asked me out there. I don't remember who now, but one of you asked. We're going to ask the question, which is the title of the book, because this is relevant to this, right? Yes. Can you give us an explanation for why you've called it this?
Yes. So a lot of people ask about the title, The Last Stargazers, because it sounds like it could be sort of depressing. I've had astronomers.
Right. That's why. That's right.
What's going on? And it sort of touches on 2 points. And the first is that the way that we do astronomy really is changing. And the sort of classical picture of astronomy as professional stargazing and the way that we used to capture data, even the way that we capture data now, is very rapidly changing. And it's great in a lot of ways. It's very positive for the science that we do. But a lot of the stories in the book sort of represent an era that we're not going to be getting back. And I wanted to write those stories down. I wanted to save those stories down because it's really a wacky little field. And some of the adventures that people had just taking pictures on sheets of glass and preparing the glass and working with the glass and developing photographs on the glass. Like, this is the whole second chapter of the book, is just looking at that history. And we're not going to observe like that again. No. But that story should be told because it was such a wild little way of doing science. So The Last Stargazers in part just references the way that we stargaze and how it's changing and how we're moving away from some of the stories in the book. It's also a little bit of a challenge because it might imply that astronomy is shrinking, or that there are fewer people interested in astronomy, and the dramatic opposite is the case. We get record numbers of students applying to our Ph.D. program at the University of Washington. This happens all over the country every year. Our astronomy major is the largest it's ever been, and this is true all over the country. There's no shortage of young people who are really eager to come in and join the field and do this research. And at every level of the field, we have more and more people who are curious, and there's a lot of universe out there. We have more than enough questions for triple the number of astronomers that we have to answer. And I don't want us to be the last stargazers. And astronomy is often very funding limited. There are limited numbers of jobs. There's limited support for public observatories, for public universities, for private universities and observatories. There are only so many pennies that ever go into scientific research. And it's a case where one more penny would make such an astonishing difference. That's multiple careers. That's multiple new projects and new facilities and new ideas. So I kind of hope to make that point to readers, saying, we don't need to be the last stargazers. There should be heaps of people answering all these questions, and we have the means and ability to do that, and we just want to support it so we don't wind up being the last people doing this kind of work.
Yeah, I think it's a great point. I want to see if anybody in the audience has questions. Feel free. I want to make sure I don't take up all the time here.
That really piques my curiosity. Yeah. Why are so many young people going into astronomy? What happened to them that caused this?
A lot of them looked up. But it's a great question. But you I think something about astronomy really captures people's imagination and people's curiosity. And something I've described it as is it's almost a gateway science, that astronomy is such an easy way to capture people's curiosity. And not everybody that looks up and becomes dazzled by the night sky becomes an astronomer. Sometimes they look at the sky and go, oh my God, this is beautiful. I want to understand how this works. And they wind up getting fascinated by physics and they go into physics. Or they realize that that's a good reason to start paying attention in their science classes and they get sucked into biology or computer science. So it's a gateway into a lot of different scientific areas, but some people really do just stay hooked on the space itself.
Could it be it's more welcoming to diversity? And so now.
Oh, that for sure. That's part of it.
This is so that has developed through very hard work by people over the decades, and that's also something that I look at in the book. The number of women, for example, in astronomy is very different now than it was several decades ago. I think in 2017, 40% of the PhDs awarded in astronomy went to women, almost half, and that number is still going up. And the racial diversity of astronomy is changing. We try to make astronomy more accessible. So hopefully this is a very positive feedback loop where we encourage people, where we show people that astronomy is a place where they can be at home and it's a place for them. And then, of course, we want to keep supporting them and have jobs for these folks when they get to the end of their time. But I'm glad to think that it is a welcoming field for people, and that's happened through effort by a lot of people who really want to open up the field, and hopefully we can keep that going.
Kathy, you had a question?
Yeah, you mentioned when you have time on the telescope, you collect data. And so the telescope is looking at the sky, and it's coming back to you on a computer screen as data. Would you describe how that works?
Yeah.
Because you personally are not looking through the telescope at the time.
Right. And this is a very common misconception that you imagine professional astronomy is a big version of what you might do at an open house or in somebody's backyard with a telescope where you look through it with your eye. And I think some of the big telescopes don't even have eyepieces.
Right.
We haven't even made eyepieces for them because they go directly to digital cameras or directly to computers. So what will happen when I'm observing at a telescope like this is I'll have a bank of computers in front of me, and there will be an interface where I can tell it, go to this exact position on the sky and point at it for exactly this long with exactly this sort of setup, and then the data will come in, and it's really exciting because you'll be pointed at the sky, you know you're taking an observation, it'll be like a really long camera exposure. Sometimes you wait a couple minutes, sometimes you wait 2 hours, and at the end of that, the data then downloads and it sort of like slowly appears on the screen in front of you, and it looks like gibberish. It looks like nothing. I think you imagine that it might pop out looking like a Hubble image, and it generally looks like junk. But you know that the data's in there. And I write about this in the book. You have to do what's called reducing or processing the data because the moon might have been shining, so there's moonlight you have to get rid of. Or there are other stars in the background whose light you don't want contaminating the star that you're studying. But once you learn, and I write about a colleague that had practice doing this. Once you learn how it works, she can look at a screen full of gibberish and say, oh, that's exciting. And look at 2 pixels of nothing and say, oh, we're going to want to look at this one more closely. So even learning how to read that data is a whole process on its own, and it comes to be beautiful in its own way. You come to look at little bumps and wiggles and go, everything's working just as it should. But it's another part of the learning process at a telescope.
What does it represent, though? Wiggles and...
It depends on what you're pointing at. So a lot of times we'll literally just take a picture with the telescope. So you'll be taking an image of a star or a nebula, sort of these little colorful wisps of gas, and you'll take a picture looking at just the blue light from a galaxy, and then you'll take a picture looking at just the red light from a galaxy, and then you'll stack those together and you make a color photo. A lot of times what I'll do is I'll take what's called spectroscopic data, and what happens there is you take the light from a star, which is what I'm studying a lot of the times, and you basically sort it out by color. You put it in a big stack and you say, well, the bluest light from the star goes here, and then the slightly bluer light is here, 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 the red light is over here, and by sorting the light out like that, you can actually get a chemical fingerprint fingerprint of the star, because different atoms will emit more or less light at very particular colors. And with practice, you can look at data like that when it comes in and say, oh, there's a little spike in orange light, so that means there's hydrogen in this star. Or there's a couple little dips way over in the blue light where there's less light, so there's probably some calcium. And that chemistry gives us an amazing glimpse into how those stars work. So the data really look like gibberish when they come in, but with practice looking at it, you can start to pull the science right out of it.
Thank you.
More questions here?
So, my mind is tired at this point. The people at the AAS were saying that, first of all, a lot of the people going into astronomy now, the young ones, like Roller Gang, they see this stuff like that's come out from the Hubble since the 90s. They see these incredible images, and so much is available on the web that wasn't in YouTube and all this stuff, and they get this all over the place, and they're just like magnetized to it. And the other thing is that they were saying that now more people who go into astronomy, like for graduate work, are coming out and going into other fields than academia. Like they're going into rocket work, or they're going into computer work, or they're going into other engineering, and all these other fields, because there's only so much available for people doing specifically that. I love what you were talking about. I love those images at parks. I did my work in Australia, and so I was the tarantulas, yes.
Yes, Australia too, yes.
And what you reminded me of with the weather is few people realized that when we had the first Apollo, the only place that could get an image was the park's radio dish, and the wind was so far above what they would ever leave the telescope on. They grounded the scope down and focused it because it was the only place in the world they could get the image of the moon.
It's fascinating. The whole story of how they studied the moon landing with parks is amazing. And there's a movie about it called The Dish. For anybody who wants to know about this.
Yeah, that was incredible. Yeah. And it was like 80 miles an hour or something like that. That's incredible. Yeah.
Questions back there?
Hi, Emily. I love your book. Can you talk about your argument for gazing based on serendipity? I felt like that was your strongest argument in the book, and I thought maybe if you could give an example of when something happened that would never have happened otherwise, and I just love that. Yeah, that is the romance, but love to hear that argument.
I swear, by the way, this isn't a planned question, but that's very much what gets covered at the end of the book, and it's one of my favorite stories in the book. But so, first of all, the idea of serendipitous observing comes in part from the way observing is changing now. That we are, and I say we, the University of Washington is a key player in building a brand new telescope that's going to be coming online in the next couple of years in Chile, and it's called the Vera Rubin Observatory. It's named for the woman who discovered dark matter, and the woman, she was actually the first woman to observe under her own name at Palomar Observatory, at the Palomar 200-inch telescope, so her story's in the book. But this telescope works very differently than the types of telescopes that I was describing, that you, instead of going to the telescope and having a list, Rubin is just going to automatically survey the sky every few nights over and over again for 10 years. And that sounds simple. It's actually astonishingly complicated, but it will give us a movie of the night sky, and it will automatically detect every star that's getting brighter or dimmer, or every little dot of a supernova that appears, or every little asteroid scooting through the sky. It's an amazing tool, but it will do it automatically. And that's a great way of discovering things. It's not the only way of discovering things. When it discovers something strange, all it will do, and I say all, it's an amazing accomplishment, but it'll flag something and go, that's weird. Point at that. What is that? And we need the combination of that and people at telescopes running them themselves at places like Magellan that can say, you know what, we have 5 minutes left in the night. Somebody said a thing over there was weird. Let's take a look at it. Let's take a spectrum of it and look at its chemistry, and you can learn shocking things from it. And this is actually where one of the biggest discoveries that my colleagues and I have made came from, because we were observing at the Magellan telescopes, and we were studying red supergiants, so these big cold red stars that I described earlier. And we had someone email us describing, there are these very strange stars that outwardly resemble red supergiants, but are actually some of the weirdest stars in the universe, because because a star like a red supergiant or a star like our sun keeps itself supported against its own gravity by fusing something in its core. They basically run little nuclear reactors in there. So they'll fuse hydrogen into helium or helium into carbon, and that's how the star stays balanced. They described these weird types of stars that weren't supported by nuclear fusion. They were supported by principles of quantum physics. They were actually supported by neutrons squeezed so close together that they actually started to fight the inward press of gravity. And their theory had been that you could support an entire star this way, which had not previously been imagined. Those stars would look like red supergiants, but their chemistry would be slightly different. So we went to Magellan thinking, let's check some of the red supergiants we've studied before and see if any of them have this weird chemistry. And it was a bit of a random search. We sort of figured we're not going to find one, but we'll learn about what regular red supergiants look like. This will be the first step in a long process. And up until the sun went down that night, we were tweaking our technique and refining our list, and my colleague Phil Massey at the last minute said, hey, there's this star that I'd like to add to the list. It's unusually red, it's unusually bright. We've added others like it. Let's get this one on there too, why not? And it wound up on our target list. Almost by luck. And we observed it, and when the data came down and it was this weird, messy, sort of like bumps and wiggles data, another colleague of mine, Nydia Morel, who's also affiliated with Carnegie Observatories, who is one of those brilliant observers that can immediately recognize data, looked at the gibberish that had appeared on the screen and said, I don't know what that is, but I know that I like it. She had seen something that Phil and I hadn't even noticed yet. And much, much later, I hadn't even realized until I was done with the work that it was the same star Nydia had recognized and that Phil had added to the list. We realized that that was actually one of these stars, we think. We think we've found the first evidence of this totally new way that a star can work. And what the Rubin Observatory is going to do, what these big survey telescopes are going to do is amazing, but it was Phil deciding to add that star to the list at the last minute and us deciding to go to a telescope and just try this wacky project and Nydia recognizing that data as soon as it appeared on the screen. All of those were really key elements in that discovery. And now what we're hoping we can do is use Rubin Observatory to try and find more. But you need all of these different tools. You can't just use a big survey telescope. You can't just run a little telescope one star at a time. Sometimes you want to do big surveys. And it's that combination that we really want to try to support going forward.
Great.
I have a question about writing the book.
Yes.
So how did you end up deciding to do this as a book? Rather, I mean, clearly you love telling stories, and the stories are great, and there's so many wonderful stories in it, but how did the book come about?
So this is a fun question, and I'll give the short answer. But I had written a couple academic books shortly after becoming a professor. I think writing those books, I wrote a book about red supergiants and a book about how stars work, and I think that got me on a list somewhere because I got a few emails from publishers saying, have you ever thought about writing a popular science book? We'd love to talk to you about this if you're interested. And I thought, no, I really haven't, but I don't know how publishing works. I'd never been introduced to the literary world in this way. So I thought, I'll sit down with them and just see what happens. And I met at a AAS meeting like the one going on right now, a guy who at the time was an editor at W.W. Norton, a publisher. And he explained how publishing worked. And he said, well, if you did write a popular science book, what would it be? And it's the only time in my entire career this has ever happened. He asked me that question, and then the idea for the book came out of my mouth. And I was sort of almost watching it happen, going, whoa, I did have an idea. It came from that first night at Kitt Peak when people told me those stories about what astronomy would be like, or it came from going out to dinner with people at these conferences because people just wind up telling stories. Oh, the dome that got struck by lightning, the telescope that was observing when Mount St. Helens erupted, and just all these wacky stories going around the room. And I remember thinking, those stories capture our imagination. I'm sure I can write these in a way that capture the public's imagination because people don't know them. And it teaches you the science. You have to learn how telescopes work and why they're interesting to appreciate the stories, and you also meet the people along the way. So that was where the seed of the book came from, was that first conversation.
Very cool. Question, gentlemen, back, sorry.
Given all the hassle of observing from the ground, what is it you can do from the ground that isn't second best to space?
That's a really good question. Right now, the best thing that we can do from the ground is just simply size. Because telescopes, the bigger a telescope is, the more powerful it is, very directly. The bigger that main mirror is, the dimmer an object you can see, and in astronomy, that directly translates to how far away we can see, and because of the speed of light, it translates to how far back in time we can see. So we are putting beautiful telescopes in space. I mean, the Hubble Space Telescope was game-changing, and we are in a little less than a month going to get the first pictures from the next generation space telescope, Hubble's successor, which is bigger than Hubble. Hubble was about 2.5 meters from end to end. The new one is 6.5 meters. So it's going to take much deeper pictures, but the biggest telescopes we have on the ground right now are 10 meters. The next generation is going to be 20 meters, 30 meters. Radio telescopes, the largest radio telescopes in the world are 1,000 feet from end to end. So you're simply working on a scale that isn't achievable from space.
I have a follow-up.
Yeah.
And can't you just beat that with lots of little mirrors?
So interestingly, that's actually how we built some telescopes on the ground, is by building lots of little mirrors and right now, instead of pouring one giant piece of glass, we'll oftentimes fit a bunch of little pieces of glass together. But say launching a bunch of half-meter mirrors into space and then coordinating them is engineering-wise an astonishing challenge. And the new telescope, the James Webb Space Telescope that's about to send us back new pictures, is a mosaic of, 7, 8, more than that, 8, thank you. It is a mosaic of small mirrors that are connected to one another. And so it had to be launched in one piece, and it was huge. 18, thank you. I was going to say
18 individual mirrors, yeah.
8 sounded small.
But it was also over $10 billion too.
Yes, this is also true. So
expensive.
Yeah, and that's the biggest telescope we've put in space. It was $10 billion to do it. And a lot of it comes down to weight, and a lot of it comes down to complexity. And those mirrors are attached. So tempting as it is to launch 100 half-meter mirrors and just synchronize them all, the engineering of that and the cost of that just quickly gets prohibitive. Whereas we are getting very good at beating the blur of our atmosphere and taking on the technical challenges posed on the ground by just having to peer through the atmosphere or deal with light pollution. Those are much easier engineering problems to fix than putting everything into space. Now, we would love to put bigger telescopes into space, but it's an endeavor on a time scale that just can't be matched by what we're currently capable of on the ground.
So for both of you, actually, do you have plans for the big 2024 total eclipse, and advice for the rest of us about how to go about it?
Where are you going to be?
Well, so this is another chapter in my book where I write about experiencing my first total eclipse, which is in 2017, and it was so cool. And
so beautiful.
There's nothing like it. It was
100% agreed.
So highly recommend it. Very worth it. In 2024, I'm actually still figuring out what my plans are, but I'm working with the same colleague that I observed the 2017 eclipse with, and we're planning to go to, I think the current plan is somewhere in Texas. I don't know. We're still sort of finalizing plans to a place where you can see totality. So the trick here is that when a total eclipse happens, you're casting the moon's shadow onto the Earth because it's passing directly in front of the sun, and that shadow kind of follows a pretty narrow path. So you have to go into where that shadow is going to be, what we call the path of the eclipse, to observe it. And if you plan well, you go into a place where it's a total eclipse for a whopping 2.5 minutes, 3 minutes, 4 minutes. It's short, but it is so worth it. And I would advise anybody to look up the path of the eclipse, look up where totality is going to be fairly long, look up where it's going to have good weather, because it's in April. I know that the eclipse passes through parts of the Northeast. As a New Englander, we don't have the best weather, so maybe further south would be good. But I would highly recommend doing that. And then people bring all sorts of eclipse viewing tools with them. We went with people who had made a lifetime hobby of traveling to eclipses, and this was their 10th eclipse. And I went with my eyes. and we wound up with like grabbing some binoculars or something like that, but just watching it with safety, eclipse safety glasses until the moment of totality, and then just looking at what a total eclipse looks like just with the eye was unbelievable. So I would highly recommend this.
You have to do it.
Interested.
Absolutely.
It's so good. Yeah.
This is the last one in the U.S. for quite a long time, so I would do it. I have a huge trip planned with I'm taking a bunch of people to outside of Dallas.
Nice.
April 8th, 2024.
Yep.
I know far too much about eclipses because after that one, which was my first total one, we had one at Las Campanas in Chile in 2019, which was beautiful. So now I've done two. So now I've become, we were planning one in 2020, but then in south of Chile, but then the pandemic hit, and then it was rained out anyway, so I don't miss it. But this is a must see. It's an app. Somebody told me.
It's astonishing.
Somebody said, I never had a bucket list, but if I had a bucket list, it would be seeing a total eclipse after seeing the 2017.
And a geeky astronomy point I want to make about eclipses too is it is one of the phenomena that, honest to goodness, sets Earth apart as very strange, because we are very lucky that the size of our sun and the size of the moon that happens to be going around us are so beautifully, perfectly matched. Mars rovers more recently have spotted Martian eclipses, and they have these two cute little potatoes of moons, Phobos and Deimos, and they pass in front of the sun and they cast a little shadow and the sun gets a little dimmer. It's nothing like what we get here. So if we ever wound up on like an intergalactic tourism circuit, people would come, or aliens would come to see our eclipses because they're that unusual. So it's amazing. Yeah.
As we're pointing out, that it's at this moment in time, because in the past they weren't the same, and in the future they won't be. So it is I call it it's a beautiful coincidence. I have a whole solar talk that about this, because it really is the right place at the right time. So April 8th, 2024, and you better know where you're at. We had one more question back there. Yeah.
Why? What's constraining the size of the mirrors? I mean, it sounds like you're just going incrementally. Why not just blow it out of the water, make a massive, unbelievable mirror right now?
It's a great question. There were plans for a while for something. So astronomers, you learn this in the book, are really bad at naming things. There's this beautiful suite of 4 telescopes with 8-meter diameter mirrors in Chile. It's just an astonishing facility, and it's called the Very Large Telescope. So there was a plan for something at some point. I think its name was OWL.
Yes.
And it stood for like the outlandishly large telescope. And it was a plan for a 100-meter telescope, because somebody said exactly what you said. They said, if we're going to do this, let's just do it. Let's just make something huge. And manufacturing mirrors, even big 8-meter mirror segments that you then mash up into a huge telescope, which is the next Magellan telescope that's coming along. Mirror manufacturing is incredibly hard. This is another story that I talk about in the book, is how you make a telescope mirror. The facility that I find most fascinating was actually at the University of Arizona, because they make the 8-meter segments of perfectly round mirrors that are now getting fitted into new telescopes. They basically have to dump an enormous amount of glass. It's the kind of glass that like a Pyrex dish in your kitchen is made out of, into an oven, and they then slowly heat up that glass and they spin the oven. If you do this with like a bottle of water, you spin it, you can watch the water settle into this nice curved shape. And that curved shape is actually pretty close to the shape you want for a mirror that will focus light. So they spin this oven for days, weeks and weeks, and they slowly melt the glass. It settles into that perfect shape. It then comes out of the oven, and the glass has to be painstakingly polished to the exact right shape that they want. They then have to cover it with this thin coat of, it'll be aluminum or silver or silica-treated silver so it won't corrode. And those mixtures are getting more and more creative all the time. But manufacturing a mirror is really difficult. So I would love if we could just make 100 meters worth of mirror, but it's another engineering challenge and it's another funding challenge. I think if we were given a huge amount of funding, somebody would go, all right, we're doing it 100 meters. But for now, getting up to a 25-meter telescope or a 30-meter telescope is in itself a huge undertaking. So we're making the leaps that we're capable of making with the resources we have right now. But everybody would be on board with going further, I guarantee you.
Yeah.
So did you get to fly on Sophia?
I did.
Oh.
Yes, so this is the flying telescope plane. So NASA operates this plane. It's called the Stratospheric Observatory for Infrared Astronomy, so SOFIA. And yeah, they fly this plane into the stratosphere, and then once it's up there, they open a rear door on the plane while people are flying on it. It's in its own little chamber. And they expose this telescope specifically designed to study light that you can only see at that altitude. So I write about the full adventure of that in, I think, I should remember the chapter numbers better. I think it's chapter 9.
At the end.
Of 8. Yep. Of flying. You know what? We cut a chapter, and I still have the old chapter in mind from the first draft. But so I write about the experience visiting Sophia and then flying on Sophia, and the history of airborne astronomy, because this is the current iteration of flying telescope. But astronomers have put telescopes on planes for years. Astronomers will fly telescopes into the high reaches of the atmosphere on balloons, on little suborbital rockets that will pop off of the atmosphere for about 5 minutes, but that's all the time you need. There's a brilliant astronomer named George Carruthers who designed a telescope that we actually took to the surface of the moon. So it's a whole chapter on sort of the telescopes that we stick way, way up in the air. But yeah, Sophia was amazing. It was a mind-blowing chance to, and I ultimately wound up flying on it for my research, but I flew on it as a reporter too, and it was a really interesting story.
We've run a while. I think we're ready to wrap up because I know people will want you to sign the book. So we want to give you time. I'm sure there'll be some individual questions. I don't know how we are doing that. Do we have details? We'll just set you up somewhere out there.
I think there's a table.
Yeah.
There you go. Please.
Yeah. Books are available on the table out here in the lobby, and then there's going to be a table where Emily's going to sit. So we're going to get your books, line up, and we'll have a little place for a lineup. There will be cupcakes.
Wow, even more important.
The bidding for the Buzz Lightyear robot has not closed. It's still there. Anyway, thank you so much for being here.